significant figures and dimensions. First, let us study about accuracy and precision. Physics is practical science in which we measure many physical quantities using different measuring instruments. No matter how careful the measurement is done, it is always difficult to get an accurate value. There will be always some difference in its measured value and actual or true value. So, accuracy and precision are measurement related words. Accuracy: more close the measurement is made to the nearer value of the actual value, more is the accuracy. And precisions: now, till what extent the resolution or the limit the measurement is made, it depends on the least count of the instrument. Now, least count makes the substance precisions. Least count less, more is the precision. That means least count is inversely proportional to the precisions. Now, to the maximum value or decimal systems, or to the extent the measurement or the instrument is used to measure, is called the least count. Like meter scale. Meter scale has the least count of 0.1 centimeter. Considering vernier calipers has least count of 0.01 centimeter. Screw gauge has the least count of 0.001 centimeter. So, least count of screw gauge is less than vernier calipers. That is, screw gauge gives more precise value than vernier calipers. Okay. Now, following precautions should be taken while measuring its physical quantities. First, choose the correct instruments having applicable or standard least count. Second one, carefully and skillfully we have to measure the measurements. Example, now 5 centimeter, 5.0 centimeter, 5.00 centimeter and 5.000 centimeter. So these are the 4 readings. So which value will be more precise? Yes, last one, that is 5.000 centimeters, because it has least count. So its value is more precise. Now, talking about errors in measurements. How far or being how safe you measure the measurement, you will be having errors in the measurement. Now, what is error? Error is simply difference between the actual value and the measured value. So, error is equal to actual value minus measured value. Considering about the types of error. First, we will look for systematic error, in which we will look for personal error and random error. First, let us consider about the systematic error. In systematic error, we have first one, instrumental error. In instruments, we find 3 different kinds of error: zero error, least count error and constant error. First of all, systematic error. Now, these are the errors same in positive or negative. Now, first, instrumental error. This error is due to the error in the instruments. Now, instruments error means it may be your scale which is broken from the 0 point and you are measuring from 1. Now suppose you are using a scale which is ungraduated. So similar problems may create an instrument error. In instrument error, we will find basically one error that is called as a zero error. Zero error. When reading taken from the vernier calipers or screw gauge, the vernier caliper or screw gauge, zero should match with the zero of the main scale. Okay, so now to relate zero error should be always, it may be or positive or negative. It may extend beyond 0 or it may be before 0. Second one, that is least count. Least count to the extent a mathematical instrument which can measure to the least value. So that kind of error is generally called as a least error. So consider an example when you are measuring a line segment by a scale which is having not a applicable least count. So measurement of this line will be always have an error, because we haven't used a proper mathematical instrument having the proper least count. Second, coming on for the further one, that is your constant error. Now, talking about the constant error, some error is repeated continuously on measuring many times is called as constant error. It may be due to the calculation of scale or calibration of scale. So, length should be measured in different points from different positions. Okay, now considering about the personal error. Personal error is the maximum cause of the personal error is the lack of experience a person is having to measure a particular physical quantity. So that is generally considered as a personal error. Next one is an error due to the external cause. Suppose you want to measure a speed of sound. So speed of sound varies from different places to different places. So this is an error which is an external, which cannot be prohibited, which cannot be avoided. Now, like temperature and pressure, these are generally the external causing activities or phenomena which causes the error. For example, if you went and you wanted to measure the length of a particular object and you found that its length was 10 centimeter in winter. Now, when you are going to measure the same apparatus or same physical substance in the summer season, you will find that its length is being increased. So that is due to the variation in the temperature, because during summer things expands and during winter things contract. So this is the type of error which can be considered to a external causing error or external error. Now, third one, considering the error for the imperfection, that is error due to the imperfections. Now, imperfection errors are generally caused, and you know the reason, you don't know the reason, but you cannot solve it or resolve it. We know that there will be error, but we are not able to resolve that errors. Now, for example, that is loss or gain of the weight due to the air. Second one, random error. Okay, so when object is measured and different readings comes for each measurements without knowing the cause are generally considered to be as a random error. To reduce it, measurement is taken again and again, and average value is taken, or it is always convenient. This average value is efficient, precise and accurate to the true value, or we can say that to the actual. Let A1, A2, A3 so on to AN are the readings observed for a particular object. So maximum true value will be equal to A1 plus A2 plus A3 so on to plus AN whole upon N will be equal to 1 upon N summation of AI, where I goes from N, 1 to N. Talking about gross error. Error due to the observer. First one, he may use ungraduated or unstandard scale or instrument. Next, noting the incorrect observations or reading. Third, not carefully measuring using the instruments. Now, the type of errors that we have discussed till now are systematic errors. First one, that means instrument error, in which we studied zero error, least count error, constant error. In constant error, we studied personal error, error due to the external cause, or error due to the imperfection. Second, random error. Third, Gross error. Now, method of expressing an error. First and two, that is absolute error, relative error and percentage error. Absolute errors. Difference between the actual reading and the measured reading is called as an absolute error. Actual or true readings cannot be or never be measured. That means we accept more reading as or mean reading as precise value or reading. Consider we have following observations A1, A2, A3 and so on to AN. So mean will be A mean is equal to A1 plus A2 so on to AN upon N, or 1 upon N is equal to summation of AI where I goes from 1 to N. So absolute error will be delta A1 is equal to mean of all the observations minus the first observation. Second absolute error will be mean minus the second value, so on. So nth absolute error will be A mean minus AN. So absolute mean error will be delta mean, delta A mean will be equal to delta A1 plus delta A2, delta A3 so on to delta AN whole upon N, or 1 upon N summation of delta AI where I goes from 1 to N. Suppose one is reading taken, that is A mean is equal to plus minus of delta A. That is A is equal to A mean plus minus delta A mean. So we can find A is the true value. So it can be interpreted that A mean minus delta A mean is always less than or greater than, less than or equal to A, or A mean plus minus plus of delta A mean is always greater than A. Second one, relative errors. Ratio of the mean absolute value and the mean value. It can be written as absolute error is equal to delta A mean upon A mean. Third, percentage error. When relative error is expressed in percentage as multiplying by 100, we get percentage error. Percentage error is equal to delta A mean upon A mean multiplied by 100. Okay, now combination of errors. Now generally we know that measurements of known physical quantities, we measure the physical quantities which measures the other physical quantities. Example, density. Density is mass upon volume. So error in the value of the density will depend on the reading of mass and the value of volume. So when one physical quantities depend on the other physical quantity, then the error measuring or the errors are called as combination of errors. Example, first one, let us take out the sum. So let the reading of two physical quantities A and B are A plus minus delta A and B plus minus delta B, where A is the reading, main reading, and plus minus is the error or absolute error. Similarly, B plus minus delta B is the absolute error. So delta A and delta B are generally absolute errors. So let us consider on adding them, that is Z is equal to A plus B. Reading them, so that is delta Z has to be founded out. So Z plus minus delta Z is equal to A plus minus delta A plus B plus minus delta B, or del plus minus delta Z is equal to A plus B plus minus delta A plus delta B. That means plus minus delta Z is equal to plus minus delta A plus delta B. maximum absolute error will be plus minus delta z is equal to plus minus delta a plus delta b. So when the two physical quantities are summed or added, then their absolute or maximum absolute errors is also added. Example, let us take the two resistance R1 and R2. R1 having the value of 50 plus minus, that is plus minus of 2 ohms, and R2 100 plus minus 3. So when they are connected in series, that is net resistance will be R is equal to R1 plus R2. So that will be 50 plus minus 2 plus of 100 plus minus 3. So it can be written as 50 plus 100 plus minus 2 plus minus 3. Or this can be written as 150 plus minus of 5 ohms. Talking about the difference, now let again consider Z is equal to A minus B. Delta Z, we have to find the maximum per absolute error. So that means Z minus delta Z is equal to A plus minus delta A minus of B plus minus delta B, or plus minus delta Z is equal to A minus B plus minus delta A minus plus delta B, or plus minus delta Z is equal to plus minus delta A minus plus delta B. So maximum permissible error is equal to delta A plus delta B. Now same as in particular example, let us take another example. Let us take the temperature of two different objects are 25.3 plus minus 0.2 degrees Celsius, and another one 72.4 plus minus of 0.3 degrees Celsius. So let us find the difference between both the temperatures. So that is 72.4 plus minus 0.3 minus of 25.6 plus minus of 2. So that will be 72.4 minus of 25.3 plus minus 0.3 plus 0.2, or it will be 47.1 plus minus 0.5 degrees Celsius. So absolute errors are again added. Coming on further, products, plus minus delta A plus minus delta B, reading of the objects, two different objects. Now on taking the products, that is Z is equal to A multiplied by B, or Z plus minus delta Z is equal to A plus minus delta A multiplied by B plus minus delta B, or it will be AB plus minus A delta B plus minus B delta A plus minus delta A delta B. Now dividing throughout by Z, so we find that 1 and 1 cancel out, so that gives us plus minus delta Z upon Z is equal to plus minus delta B upon B delta A upon A plus minus delta A upon A delta B upon B. Now considering about delta A upon A delta B upon B, that is a very small and a diminished value, like 0.0001 multiplied by 0.001. So with the value which you will get will be a very small value. So neglecting those small terms, we will get plus minus delta Z upon Z is equal to plus minus delta A upon A plus minus delta B upon B, or delta Z upon Z is equal to plus minus delta A upon A plus delta B upon B. Alright, division. Now Z plus delta Z is equal to A plus delta A upon B plus minus delta B. Now taking B plus minus delta B from down to up, it will be raised with the power of minus 1. Before that, taking A and B as common, so it will be A bracket 1 plus minus delta A upon A whole of upon B 1 plus minus delta B upon B, or it can be further written as 1 plus minus delta Z upon Z is equal to A upon B that can be written as z, and further it can be written as 1 plus minus delta a upon a whole upon 1 plus minus delta b upon b, or it can be written as 1 plus delta a upon a bracket close bracket 1 plus delta b upon b whole to the power minus 1. Applying the binomial theorem, we can write it as 1 plus delta z upon z is equal to 1 plus delta a upon a times of 1 minus plus delta b upon b raised to the power is introduced inside binomial theorem. So further multiplying, we will get 1 plus delta a upon a plus minus delta a b upon b minus of delta a upon a delta b upon b. Again neglecting delta a multiplied by delta b whole upon ab will give you as plus minus delta z upon z is equal to, that is delta a upon a plus delta b upon b plus delta a upon a dot delta b upon b. Or further, it is in simple order, it can be written as delta z is equal to delta z upon z is equal to delta a upon a plus delta b upon b. So further moving for the power, that is z is equal to a to the power m. So z plus minus delta z is equal to a plus minus delta a whole to the power n. Taking a to the power n common, so it will be 1 plus minus delta a upon a whole to the power n. So that is a to the power n 1 plus minus delta a upon a whole to the power n. Expanding using the binomial theorem, it will become a to the power n 1 plus n delta a upon a. So further it can be solved as, that is delta z upon z will be equal to n times of delta a upon a. Okay, consider an example. Let us consider an equation in which we will be having more clearance and more clear idea about the expression. So let us consider a formula where we find that z is equal to a to the power n, b to the power m upon c to the power 1 or d to the power q. So it will become delta z upon z will be equal to a to the power n will be written as delta a upon a plus next b to the power m will be written as m delta b upon b plus of c to the power 1 will be written as delta c upon c plus of d to the power q or p will be written as p or q delta d upon d.